is time for the final and overly dramatic episode of the Pile of Commodore 64s, where we will take whatever is left in the pile and try to create some sort of Frankenstein's monster out of it. Starting with the plastic, this was a plastic from Exhibit A, which was very yellow. And I promised to show you how to make it look less yellow in a Lagom effort way. Here we go. Yeah, no peroxide for you people. Now, I think this brown keyboard looks awesome against the yellow case, so I'm not going to retrobrite anything. And to explain a little bit how I got hold of it, this is from an old bread bin version of the Commodore 64, and I managed to find a very nice guy in France that had one available, and this is the reason. He has a band, and he's into circuit bending, and the SID tune you're hearing in the background is made on these machines. And this all made me revisit the idea of using the Commodore 64 for music making. We'll see if I get anywhere with that in the future. And in the meantime, I think you should check out their YouTube channel. It's good stuff. So the first two pieces of my monster is gathered, and I like the triple action on the guitar there, by the way. The case needs some cleaning, and this badge here looks really sad. We need to do something about it. It's been, it's been removed and bent. The sticky tape is all dirty, and the badge is... I have no idea how this happened, but I do know how to get it fixed. I'll take a soft surface. This is a mouse pad actually, a thin mouse pad. A metal rod and a ball bearing, and I will just roll this back and forth to see if I can get the metal in this aluminium badge to loosen up a bit and flatten. That'll do. And after cleaning up the case and the badge with some isopropanol, it actually got stuck, so I couldn't get it loose anymore. Next up, we'll actually do a little bit of a build. I have bought this RiboCop kit from RiBIT, and this is designed to serve the power supply's trust, protect the innocent board in the computer from overvoltage, and uphold the integrity of the chips. This reminds me of something. Never mind. All the RiBIT kits that I have tried so far, namely being this one and the Pi 1541, they are actually a bit of a challenge. There is a lot of surface mount, and in this RiboCop, everything is surface mount except for the connector and the capacitor and the cable. And the components are quite small, and it's obvious that this card is a little bit of a, let's say, a beta version. There are some things, some tracks on the card that needs to be cut, and there are some patches that needs to be done. They are included in the manual, so it's not difficult to do it. But it's obvious that the card has some bugs in it, physical bugs, not the physical actual living bugs. But yeah, never mind. The components are quite small, and I think the most tricky one to solder in is the resistor networks. There are 3 resistor networks, which is basically 8 pins of no millimeters at all, and I have tried to solder this model with a conical tip. Yeah, conical tips and surface mount components are a good combination in very, very specific cases, and this is not one of them. So I had quite a bit of trouble to get the resistor networks in place. And the other components turn out quite good, actually. The solders are completely fine. One thing to well, I will not tell you that I actually mixed up the transistors, so I had to resolder them. But here you see the resistor networks, and they are tiny. These are really, really tiny. And I actually cheated a bit. I used hot air on them because I couldn't get a good bond on some of the pins there. I think it's probably possible to do this with a lot of flux and a different tip, but the conical tip, no, it didn't work well for me in this case. Now the RiboCop kit is quite cheap, and it costs quite a lot more if you want it pre-built, but if you're uncertain, I would certainly recommend it. Testing it with an adjustable power supply, we can see that at 6 volts it kicks in the protection. To be honest, I would have liked this to be more like 5.5 volts, but I'm sure there's a reason. I guess usually when the power supply fails, it does that with bursts and spikes of high voltage, so this will kick in and stop delivering power, so I think it'll do nicely. It comes with a plastic box, and it's a very tight fit, but probably a lucky fit, to be honest. Holes, markers for the holes are pre-drilled, and here we can see it all in its glory. 9 volts being indicated by the blue LED, and the green is confirming that our 5 volts is good. So time to put the last of the pile of Commodore 64s together. And here we have the Exhibit B card. This is the one we took the case from, the case that wasn't so yellow. And we'll put it in the Exhibit A case. We have some components missing on this card. One of them being the PLA chip. I have this modern day replacement I showed you in the first episode from FPGA Arcade, and that'll do for now. I'm not planning to buy any new one. Worst case, if I need a PLA chip, I can always rip it from one of these 3, unless I sell them. SID chip though, we need a SID chip, and instead of going for the stereo SID again, I got the older version of ARMSID, the plain single SID replacement. So it's actually quite configurable and nice as well. It can auto detect between the old and new SID versions by reading the voltage of the pins on the motherboard. So it emulates whatever SID was original in the card, and yeah, I like that. You can always force it to emulate the other SID chip if you find the characteristic of that one being more to your liking. And we click it in. So yeah, what's next? I guess we'll plug in the keyboard and make sure everything is working as it should. First with the diagnostic cartridge. It runs nicely. The PLA and RAM seems to be testing okay. We also see the time of day clocks. The color RAM and the ROM check, everything checks out, and the keyboard seems to respond. So that's nice. We'll boot up with the help of the Pi 1541. We'll boot up the ARMSID testing program. Here we can see that it's detecting 12.3 volts roughly. So therefore it is emulating the 65 series, so 6581 I guess is the version of the SID chip. And you can adjust a little bit of the settings on it, but there's not as much to do on this one as it was on the stereo SID, of course. So let's load up something and see if we get in sound. That is certainly a noise. And it only came from one of the speakers, and that's because I'm using a stereo SID compatible cable. Yeah, this is nice. Sound quality is fine. Before we finish putting this computer together, I will do a modification actually on the board, because I'm going to use a stereo SID compatible SVGA, or sorry, S-video cable all the time. I want to make sure I get the sound in both channels all the time. So I'll actually just do a bridge here on the audio-video socket between the sound pin and pin 7, which I use for the second channel on the stereo SID. It's just a simple matter of putting a bridge between the two. The pin 7 is not used for anything originally, so there is nothing that can be toasted or fried or boiled by this treatment. That'll do nicely. And now it's time to get the monster back together, and I usually plug the cables in because it's easier to get the board aligned when you tighten the screws. And I also found the brackets. The brackets was in a box next to the pile, where the pile used to be, and everything is complete, so that was lucky. And with the final 3 screws of the plastic case, the entire pile of Commodore 64 is finished. Not 1 or 2, but 3 of the donor computers in the pile of Commodore 64 actually made it to a functioning state. And we'll look at them and see what we did. The first one, the Swedish one, it was clear that it had been through quite a lot. It was quite dirty, and it had quite a dusty motherboard and a fair bit of broken components on it. But with the help of Exhibit B, we managed to have a clean, nice looking case, and we got the Plankton, the PLA replacement, together with a new color RAM, and in the end we got a fully functional Swedish Commodore 64. Now Exhibit B, which in the end turned into our Frankenstein's monster one, was also a little bit odd. Just like the first one, it had a motherboard that was not really the model that was expected in the C64C models. It was actually a board that was very common with the bread bins. So apart from this confusion, we needed to get a PLA replacement, and I used the one we had on the shelf. Also needed a SID replacement because I stole the SID for Exhibit A. And with the new keyboard, everything turned out fine, and the yellow of the case actually turned out to be a benefit against the bread bin style keyboard. And the last one, the expected one, was actually a proper C64C with the short board, the super PLA and everything that we were expecting. It was missing a SID chip, and because it is the short board, it has a 9-volt SID chip, so we couldn't just move over anything. We put the ARM2 SID in it, and we also put a Lumafix 64 because short boards are known to have issues with digital interference in the video output. And the CIA chip, we didn't get any graphics, so we swapped it over for the other CIA chip that controls the keyboard, and the graphics came back, but we had to source a new chip for the keyboard. So there is a pile of chips, and from the pile of Commodore 64s we actually managed to repair them all, and I'm very happy about that. I'm very grateful for all the positive feedback throughout the series so far, and special thanks to people like Stephen White and BWAC and Dave Murray and others that has contributed in one way or the other to this channel. And we have now reached 100 subscribers, and that's awesome. Running a channel like this doesn't come cheaply in either time nor money, but getting the possibility to light up the way for everyone passionate about this subject is a big reward in itself, and I thank you very much for being subscribers. This pile is sorted, and the next pile will be one of Apple II. So stay tuned, and let's see what we can do with that one.